So welcome back students. Now we will discuss the series related to the natural numbers, sum of natural numbers, sum of squares of natural numbers, and cube of squares of natural number, and the method by which we can find their sum. Okay. So first of all, always remember a thing. When we write Sn means sum of n terms of a series. Means what? A1 means A1 means first term, plus A2 means second term, plus A3 means third term, and so on up to An means nth term. So we can represent it in summation form. Remember, this is the notation which is used to represent the sum of some terms which are defined by a natural number n. So these are the first n terms of a series whose sum is given by sigma. Now we write I equals to 1 to n ai. Means in place of I, we can substitute 1 to n all the natural numbers one by one. Means 1, 2, 3, 4, 7, 5 and so on up to n all natural numbers and their sum. This summation represents sigma I equals to 1 to n. We read it as sigma I is equal to 1 to n ai. And in short, we can also write it as sigma an. Sigma an means also the same thing. Sigma an means a1 plus a2 plus a3 and so on up to the natural number n. Starting from, as we know that natural numbers are starting from 1 until n, we have to use its value, and sigma means their summation. Sigma represents the summation. So always remember Sn equals to sigma an. Sn equals to sigma an. Okay. So this is the most important theorem when we find the sum of natural sequences. Like the first is sum of first n natural numbers. That is 1 plus 2 plus 3 and so on up to n. So using this principle, sigma an, we can write it as sigma n only. If you use the value of n as 1, first of all, I have told you n equals to 1 to n, so on up to n, find the sum of all the terms. So if you use n equals to 1, it is 1. When you use n equals to 2, it is 2. When you use n equals to 3, it is 3. So 1 plus 2 plus 3 and so on up to n is denoted by sigma n. Now how to find this sigma n? Remember, 1 plus 2 plus, wait, to understand more, sigma n equals to, we are writing 1 plus 2 plus 3 and so on up to n. And which type of series is this? You can find a equals to 1 and common difference 2 minus 1 equals to 3 minus 2 equals to 4 minus 3 is always 1. And we know that sum of n terms of an AP, this is an AP na, as common difference is common. So n by 2 into first term plus last term, that is nth term. So n by 2 into first term is 1 and nth term is n. So sigma n, which is the sum of 1 plus 2 plus 3 and so on up to n, is equal to, always remember, n by 2 into n plus 1. So this is the formula for sum of n terms of sum of first n natural numbers, which is denoted by n by 2 into n plus 1. Okay. Sum of first n natural numbers is given by n by 2 into n plus 1. The third theorem is about the sum of squares of first n natural number. So we write sum of squares of first n natural numbers. That is what? 1 square plus 2 square plus 3 square plus 4 square and so on up to n square, which is denoted by sigma n square. Remember, the nth term and sigma before this. Nth term is n, so sigma before this. Nth term is an, so sigma before this, sigma n. Okay, this is the method of writing the sum of the series whose domain is a natural number, sigma n square. So how to find this value of sigma n square? So remember the formula for this. In next sessions, we will discuss the proving of this formula also in next session. Okay, first learn it only and try, and we will learn how to use it. Then we will learn how to derive this formula in next session. Okay, so sigma n square equals to 1 square plus 2 square plus 3 square plus 4 square and so on up to n square, which is given by n by 6 into n plus 1 into 2n plus 1. So learn this formula also. This is the formula to find the sum of squares of first and natural number. Sum of first and natural number is n by 2 into n plus 1. Sum of squares of first and natural number is n by 6 into n plus 1 into 2n plus 1. And the next is about the cubes. So fourth we find sum of cubes of first n natural numbers, that is 1 cube plus 2 cube plus 3 cube plus 4 cube, sum of cubes of first and natural number means till n cube, which is denoted by sigma n cube. And remember this sigma n cube, that is 1 cube plus 2 cube plus 3 cube. Its proving will also be discussed in next sessions. It is n square by 4 into n plus 1 whole square. Or if you observe the formula for sigma n, it is n by 2 into n plus 1. So we can write sigma n the whole square. Sigma n cube is not, doesn't mean sigma n whole cube. Okay. Sigma n square is different from sigma n whole square. Sigma n square is n by 6 n plus 1 2n plus 1. And sigma n cube is n square by 4 into n plus 1 whole square. So you have to learn these three formulas first of all to solve the questions of spatial sequence which have natural number as their domain, like this question. Find the sum to n terms of the series 1 square plus 3 square plus 5 square. So first we write question number 2a. 2a. So sorry, it is 3a. To question 2 we have discussed in previous sessions. In question number 3a, we have to find the sum of the series. With first term 1 square, second term 3 square, third term 5 square and so on up to n terms. So first of all find the nth term of this series. So what is the nth term? So look at this. It is the nth term of 135 whole square. As first term is 1, so its square is given by first term 1 square. Second term is given by square of 3. Third term is given by square of 5, which is the third term of this series. So nth term will be given by square root of this 135 series. So how, which type of series is this? You can observe it is the AP, as its common difference is common. 3 minus 1 equals to 2, again 5 minus 3 equals to 2. So we can use the formula for nth term of AP. We know that is it is a plus n minus 1 into d whole square. Now a is 1 plus n minus 1 into d is 2 whole square equals to 1 plus 2n minus 2 whole square equals to 2n minus 1 whole square, which is the nth term. So expand it. It is giving 4n square minus 4n plus 1 using the formula a minus b whole square. So we have calculated the nth term of this series, which is neither an AP nor a GP, nor an AGP. It's a special sequence. These types of sequences are called natural sequences. Okay. So we have first to find their nth term, then to use to find Sn. We can write the nth term as Tn or by An also, sigma T. This we have discussed in the theory of this part. Okay. Sn equals to sigma Sn. So if nth term is Tn, the Sn equals to sigma Tn. Okay. So we have used sigma Tn to find the sum to n terms of this series. Now Tn we have calculated. It is 4n square minus 4n plus 1. So we separate it first of all. Sigma, we write 4n square minus sigma 4n plus sigma 1. Now 4 into sigma n square minus 4 into sigma n plus sigma 1 means 1 plus 1 plus 1 and so on up to n times. So its value will be n. Is that clear to you? Sigma 1 means 1 plus 1 plus 1 and so on up to n terms. So 4 into and sigma n square formula we already have discussed. It is n by 6 into n plus 1 into 2n plus 1. Look at this. We have discussed its theory that sigma n square, that is 1 square plus 2 square plus 3 square plus 4 square and so on to n square, is given by n by 6 into n plus 1 plus n plus 1 into 2n plus 1. So in place of sigma n square, we use 4n by 6 into n plus 1 into 2 plus 1 minus 4 into sigma n. Formula for sigma n also we have calculated. It is n by 2 into n plus 1. Look at this. Sigma n equals to n by 2 n plus 1. And its meaning is sum to first n natural numbers. Okay. Then we write 4 into sigma n is n by 2 into n plus 1 plus, and this 1 plus 1 plus 1 is 1 up to n. I have told you that its meaning is n. So 2n by 3 into n plus 1 into 2n plus 1 minus 2 to the 4. 2n into n plus 1 plus n. Now in all these terms n is common, and if you find the LCM of denominator, it is 3. So first term is 2 into this n by 3 is taken common into n plus 1 into 2n plus 1. In second, n is common and LCM is 3. So this will be multiplied to the second term. 2 3 is 6 into n plus 1 plus. In third term, n is common. So we will not write n. But 3 ones are 3 will also be written. Okay. So the next thing is it is equal to then n by 3 into, open the bracket, 2 into 2n square plus 2n plus 1, 3n plus 1 expanded to get this minus 6 and minus 6 plus 3 equals to n by 3 into 4n square plus 3 to the 6n plus 2 minus 6 and minus 6 plus 3 minus 3 equals to n by 3 into 4n square, 6 and 6n cancel out, 2 minus 3 is minus 1. This is the answer of the given series. 1 square plus 3 square plus 5 square and so on up to n terms. So the procedure is that first we have to find the nth term, and we observe that except this square, it's a GAP. 1, 3, 5 and so on up to n terms. So find its nth term, which is obtained by the formula a plus n minus 1 into d, where a is 1, d is the common difference, 3 minus 1, 2, whole square equals to 1 plus n minus 1 into 2 whole square, that is 1 plus 2n minus 2 whole square, 2n minus 1 whole square. On expanding, it is given 4n square minus 4n plus 1. So we find the Sn by using sigma Tn. Remember always this. Sn equals to sigma Tn, and its reason also we have discussed in the same session today. Okay, so sigma Tn means sigma of Tn. Tn is 4n square minus 4n plus 1. When we separate it, it becomes 4 into sigma n square minus 4 into sigma n plus sigma 1. So 4 into sigma n square is n by 6 into n plus 1 into 2n plus 1 minus 4 into n by 2 into n plus 1 plus n equals to 2 to the 4, 2 3 are. So 2n by 3 into n plus 1 into 2n plus 1 minus 2 to the 4, 2n into n plus 1 plus n. Now out of these three terms, n is common. Denominator is 3. So it is 2 into n plus 1 into 2n plus 1 minus 6 into n plus 1 plus 3. On simplifying further, it is giving n by 2 into 4n square minus 1. Similarly, we can solve all the questions of this series with the same method. First, we have to find the nth term and then use the sigma like this 2, 4, 6. Its nth term will be 2n. Okay. Then we use Sn equals to sigma Tn. This is 2n or whole square is also there. So 4n square. So sigma 4n square, that is 4 into sigma n square. Clearly 4 into n by 6 into n plus 1 into 2n plus 1. So continue to solve these questions and ask your doubts so that I will further discuss the other questions from this sheet. Okay. So continue the sheet and ask your doubts in comment box if you have any. And watch the videos and correct your mistakes. Okay. Understand the concept.